So I'm Frank Coyle from SMU in Dallas, and I am going to give you a high-level overview. And what I'd like to do is give you some context for where the generative AI materials fit into the grand scheme of things. So I want to try to give you a short intro to the history of AI and where and how we've gotten to the point where we are today. And then I want to do a little dive into how large language models work, what they're doing under the hood to give us the kinds of information that they do. So let's jump over to the first slide. And so in the early days, so AI has its origins in the 1950s when some of the early computers were on board, vacuum tube computers, and people were very interested in how these computers could imitate, simulate, create intelligence. And so the early materials were on chess and gaming. Then we had the expert system revolution. We had a number of AI winters. Robotics plays a part in the artificial intelligence world. Then in the 1990s, we had the rise of the internet and the web. And that gave us a tremendous amount of data. We also had high performance computing. We had the rise of the GPU, which you all know is now the hottest thing with NVIDIA basically sells GPUs, which are used to teach machines how to understand all things about the world. And neural networks are a basis of this. And then we now, on top of all this, we have things called what we're calling large language models, ChatGPT, BERT, number of different items. So the next slide you see is something I asked DALL-E to generate for me, which would encompass the many dimensions of artificial intelligence. And you see this just kind of weird stuff that it makes, but it tried to bring together all the things that I mentioned in the previous slide. But as you see, it's not really good at spelling. It's good at making images. So the words are kind of related. You see numeral processing and so forth. So let's jump to the next slide. And I'm going to try to take you to a dive into the technology behind large language models. So what does it take to build a large language model? What does it take? It takes data, lots of data. So these large language models have been ingesting every web page you can find on the web, books, PDFs, documents, images, just digesting it. And the big players, Google, Microsoft, OpenAI, have the machinery, have the compute power to really grab all this data and process it. And so when it gets this textual data, it breaks it up into words called tokens. So we words, parts of words. And these words become the basis for its understanding of the universe. Now, all these machines need numbers. They all work with numbers. And so they take these words and they break them into numeric representations. These numeric representations are called embeddings. So you drop to the next item. So embeddings are really the key about how this works. So what does an embedding of a sentence look like? Well, let's take a look at the next slide. We'll see that. So if you have a sentence, the prosecution approached the bench. This will be converted into this giant array of numbers, floating point numbers, all between -1 and 1. And this huge collection of numbers is the basis for what large language models do. This represents their understanding of the text. So this giant embedding captures. Let's take a look at what is in this chunk of numbers. It understands the syntax of the word. So when it sees the prosecution approaches the bench, it sees that the prosecution means sort of a collective noun rather than a verb. It also captures the semantics, the meaning of it. It captures the relationship of these words to other words, what words go together in sentences. It understands that. Relationships and analogies. And if we play with ChatGPT, we can see this as it comes, as it answers our questions. It also understands hierarchical information. So all this information is brought together in this numeric model. Okay. Now, here's the weird part. How does it do this? It creates an n-dimensional space. Now, what do I mean by n-dimensional space? Let's look at the next slide. You can see easily this is a two-dimensional space. It's got an x-axis on the bottom. It's got a y-axis on the side. We can easily, as humans, understand a two-dimensional space. We can also understand three-dimensional spaces, which require three numbers, x, y, and z. We live in a three-dimensional world. Now, take those three numbers and expand them. We are now, the large language models live and think, I'm going to use that word not accurately, but it's doing its processing in a multi-dimensional space. So how big is this multi-dimensional space and what does this mean? Let's take a look at that next slide. If you look down at the lower right-hand corner, you see that, and this is sort of a collapse of n-dimensional space into a two-dimensional space that we can understand. So as it goes through all this text, words and phrases that are close in meaning are close together in this n-dimensional space. So a puppy and a dog and a cat are much more closely related to each other than, let's say, a house or a potato or a satellite, okay? And all these terms are floating in this space. And when the large language model, like ChatGPT, gives you an answer, it is searching in this space for concepts that are close and allows it to predict the next word in its stream of output. Now, how big is this space? This is what's mind-boggling. GPT-1 had an embedding space of 768 dimensions, okay? GPT-4, 4,096 dimensions. GPT-3 is 4096. GPT-4, they haven't revealed it. So it's, a lot of the companies are keeping things closed because they have their algorithms that do things. If you all watch the reveal of GPT-4o, you find that even the engineers were surprised at what kind of capabilities were coming out of these models. Okay. Common term that we run into, and it's important to try to understand what hallucinations mean. We often talk about, oh, this large language model is hallucinating. Well, what does that mean? They are trying to return the closest answers based on the distance between terms in this n-dimensional space. They try to give their best answer. Sometimes the answers are close to what we want, and sometimes they're farther away based on the data that they have. So an incorrect answer is simply 2 points in space that are the closest, but not really on the mark. That essentially is what a hallucination is. It's a measure of closeness, but it's like no cigar, okay? And the last, okay, and now we're at the end of the shallow dive. So that's essentially how these large language models work. It's very difficult to get our head around it. This is why we can't understand how or why these models are delivering answers that they do, because they're processing in this contextual space that we as humans cannot really grasp. Okay, now, one of the big items that is affecting the legal profession, is affecting every profession, is the concept of generative AI, where these models are creating things, creating images, creating text, creating voice. How does this happen? There's there's a technology that comes out of the neural network world called generative adversarial networks. And the way this works is you have two programs. One program tries to create something, let's say fake currency. So you have this program trying to create fake currency. You have another program called the discriminator who gets a real picture of the currency and whatever the generator is generating. So the discriminator, says, well, this is a terrible example. You're really way off. This is the real deal. So then the generator then uses the information to adjust its algorithm. And this process occurs hundreds, thousands, millions of times until the discriminator cannot tell. It's a 50-50 chance from the real or the fake. And this is how these deep fakes work. Just constantly training. So let's look at just a few examples that I found on the web. One of the things people use this for is face recovery, which I think is impact for the courts. So I have this blurry image that I captured. Applying generative AI technology, and given all the faces that I've seen in my learning, I can generate a much clearer image of the individual, okay? But again, this is just based on the data that it had. Another very, very current technique that Google has had for eye contact, eye focusing. So you're making a Zoom meeting, you're doing a Zoom meeting, and the camera's in front of you, and over on the side, you have the data or documents that you're looking at, and you're kind of reading your slides from the side, and you record the video, but it doesn't really look good because you're not facing the camera. You can do this eye focus adjustment. It'll change your eye focus, change your face, move it, and be right there. So that's my rapid fire overview of AI. If you have questions, happy to answer them. If you want to reach out to me, got some links down here, my email, and I've got some articles on medium.com. I find that a really good way to keep up with some of the technology, and LinkedIn, of course, you can connect there too. So happy to answer questions you might have on this very interesting technology.
Hey, thank you, Professor. That was tremendously helpful. I really appreciate it. Could you expand a little, if you think it'll be helpful, on the generative portion where you say there's kind of a generator, right? And then there's a discriminator counter program. But what I can see if a human was interfering, like how they could have something outside the system to say, oh, this is a fake, this isn't a fake. But presumably there's not a human discriminator. So how does that discriminator decide what looks genuine and what doesn't?
So, okay, very good question. So the discriminator, so the way it's set up is it has a collection, there's a collection of actual images. Okay, so for example, I'd have a collection of pictures of real currency. And then I would give a picture from the real currency, and then the generator would have its image. We know which is the correct one. And so the discriminator would try to pick. Now we know what the real answer is. If it picks wrong, based on the discriminator's answer, and we know what the real answer is, the discriminator is trying to catch the fakes, and the results of that, the algorithm will then say to the generator, you have to get better. You're not fooling the generator, or you just fooled the generator. The generator picked you, so whatever you were doing, increase the weights on the algorithm that's actually generating the items. So it's actually there's a framework in which this is happening.
Got it. Thank you. That's really helpful. I appreciate it.
But I do have a question for you, Professor Coyle. And when we were at the meeting where we met, some public defenders were very concerned about the black box of AI. And that if there's evidence introduced in court that is in some way produced by AI, they want to know how you got there. And so they want to know what's in the black box. And I'm wondering if you can tell us, can we see what's in the black box?
We can see, but, big but, what you see is a sequence of numbers that represent the neural network model that created the answer. So in essence, we can see, but we can't understand. So in essence, we cannot say why this occurred. And so this is what's happening now. GPT-4o is surprising, has surprised its developers. There's like, wow, we didn't know it could do this. We only thought we were going to have this happening. And now it's able to understand nuances of emotional, it can kind of sense the emotions of the speaker. We didn't think that this could happen. So this is a really tricky area. I mean, when you look inside, all you see are these numbers. And there's no way you can explain to someone why this is happening. And again, it gets back to that dimensionality thing. We cannot think in this multidimensional space. It's kind of frightening in a way. It is. I mean, there's this, love-hate relationship with this technology.
With the photograph you showed, the blurred image that is then cleared up and we see a face there. Would a different computer with a different program system, could it come up with something that looks completely different?
Yes, if it has been, if it has only seen a certain collection of images, so it's basically refining the image based on images that it has seen of people, but millions of images of people. But this is where the concept of bias can come in. If it's only looking at certain racial groups, certain ethnic groups, it's going to tend to make people look like that because that's what it thinks humans look like. So yes, there is there is potentially a difference with what different models will create. Just as when you go to ChatGPT or you go to some of the other large language models, you get different things out. Also, they're also programmed to do this sort of randomization within this space. So if you ask ChatGPT the same question twice, it's going to give you slightly different answers. It's not going to give you the exact same answer because there's this randomization within this. You imagine this space of floating concepts. And it may go over here or there, it'll do close answers. So the answer is yes, different models will give you different results.
Joe, did you have a question?
I was more responding, I think, to what Professor Coyle was saying, which in some ways, we really can't address the cognitive bias developed with AI unless we accept that AI is a tool. It can't replace a human, sort of reviewing some things from a forensic standpoint, because you do have that bias. And the only difference between us and AI, it's not the only difference, it's a poor phrase of words, but essentially is my 2-year-old can't go from 2 to 60 in a matter of weeks. I have to wait for it. But the way I teach him, he's going to be inherently biased one way or the other about it, which is why, when he says something, he needs to relook at it and say, all right, well, is this accurate? Which I think AI is a complement. It's a tool. And I think from a forensic standpoint, I think from a court standpoint, I think we're going to have issues unless we fully flesh out the bias issue and how it learns and the differences within and how hallucinations are developed. So, I mean, no, so it was more just can we address the cognitive bias, within the infrastructure? I don't think we can, but I wanted to get Professor Coyle's opinion on it.
Yeah, I mean, the bias is simply the inferences made from what the model has been fed. So that I think there's a bias inherent, and some of the large language models, you know, they have this concept of open source, closed. Some of the models are closed. They won't reveal where they got their information from. Some of the models are open and they will tell you. But even then, yes, we looked at 7 billion documents, and that's the basis of what the model returns. And that also raises its own set of problems. Okay, what now? How do we go through 7 billion documents to try to ferret out where the bias comes in? So it's a really tricky problem.